In this last lesson of the unit, we're going to look at situations where we have two different relationships, and we're trying to make a comparison between the two. Often these two relationships will meet at some point. We're going to call that the point of intersection. And we're going to start with an example just to get an idea of how this is going to work. So we've got Plum Crazy Plumbing Services. They charge $20 an hour. A competing business, Leaky Business Plumbing, charges a service fee of $30 plus $15 per hour. We want to write an equation for each company. So we have two different companies, each of which has an equation. Okay, each of which has the same variables. The number of hours that you need them for, plus how much money they charge. Okay, there's our net statements. Let's talk about the different companies. We have Plum Crazy, I'm just going to call that PC. Their equation is y equals, what do they charge? Just $20 an hour, so 20x. Leaky Business, they charge a service fee, so that's an initial value, plus $15 an hour. And there's my two different companies. Okay. Let's graph these two equations. So we have our graph down here. We'll add some numbers to it. So number of hours, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our pattern over here is going by 20s, it looks like. Okay. Easiest way to make a graph is to make a quick table. So let's do that. I'm going to kind of cheat here because we're doing two companies at once. Let's do this. Number of hours. And then we'll have Plum Crazy and their cost. And we'll have Leaky Business and their cost. Alright, so what do we want here? Let's go for 0 hours, 1, 2, 3, 4. That should be a good start. Find the pattern. Okay, Plum Crazy, what do they start at? Well, initial value of 0. And for every hour, they charge $20. So 20, 40, 60, 80. All right, Leaky Business starts at $30. That's their service charge. And then they charge 15 an hour. So 45, and then 60, and then 75, and then 90. Going up by 15s each time. Let's graph this. So 0, 0, that's a nice one. 1 hour is $20, and 2 is 40, 3 is 60. These are nice dots right along those points that we already know. There's Leaky Business. Oh, sorry, Plum Crazy. Leaky Business starts at 30, so we have to estimate that one right in the middle there. Then 45, which is actually a hard number to graph, so I'm going to skip that one. But 2 and 60 I can find. 75 is hard to graph. 4 and 90, I can estimate that one pretty closely. And this one seems to have a pattern too. In fact, if we were to extend our table just a little bit further, let's see what happens. If I went to 5 hours and then 6 hours, and I'm cheating because I know what's going to happen here. But sometimes if we make our table just a little bit bigger, following the same patterns, we notice something. Okay. When I get to 6 hours, they both charge exactly the same. I kind of need to make my line a little straighter there. There we go. That's our big idea. Okay. Part C, when would the two plans cost the same? In other words, when do they intersect? When do they meet? Well, that's kind of the big idea today. They meet, okay, the lines meet at 6 hours and $120. Both companies cost exactly the same there, which is good. Good to know that. So if I have a job that's going to last 6 hours, it doesn't matter which company I go for. But if my job doesn't last quite as long, I have options of who I should choose. So Plum Crazy would be good for jobs that take how long? Well, which one is Plum Crazy? This is the green one. Plum Crazy starts cheaper, right? Oop, there's a different color there. Plum Crazy is the one down here, the low one, the one that's no initial value. That's cheaper up until 6 hours. However, after 6 hours where they meet, they actually get to be more expensive. Their line is higher. So in this section of the graph, after 6 hours, the blue one is cheaper. That'd be a leaky business, right? So usually when we talk about these kind of questions, when I say which of these companies is better, the answer is going to be, it depends. Depends on how many hours you need them for. That's what's going to usually happen for pretty much every competing company question we're going to look at. It depends. Okay, let's look at another example. Okay, this one, the picture is drawn for us. The pictures aren't hard to draw. They're making tables and graphing them. But what we really want to do today is analyze competing companies, competing situations. So we have an amusement park that offers 2 options for entrance as shown in the graph below. Which of the following statements about the options is true? So option 1, it looks like there's an initial value of 35 and then some sort of rate. Option 2, it costs you $70 but seems to stay at 70 no matter what. Here are the situations we want to look at. Okay, for 4 visits. 4 visits. Here's 4. 4 is right there, and 4 is right there. We're comparing them. Option 2 is cheaper. Well, option 2 to me looks like it's the higher of the 2. So that's definitely not true. That's a false statement. It's actually more expensive, regardless of the numbers. Okay, for fewer than 8 visits, 8 visits this time. Here's 8. Let's go up and look. We got that number compared to that number. Okay, for fewer than 8 visits, option 2 is cheaper. Well, if it's exactly 8 visits, option 2 is cheaper. But if it was only 7 visits, this one right here, they're actually the same price. So I don't know that this is true for fewer than 8 visits. I think that's kind of a false statement too, right? Okay, for 11 visits. 11 visits, that's over here. Let's go up. 11 and 11, comparing them. Option 1 is $10 more expensive. Well, it's definitely more expensive. Let's see how much. Option 2 is 70. Option 1 is 90. Is that $10 more? Nope. That's false. It's $20 more. Okay, I'm going to guess the last one must be true, but let's just make sure. 7 visits. 7 visits is right here. Okay. For more than 7 visits, option 1 is more expensive. And that's true. Right? If we went for 8 visits, it's more. If we went for 9 visits, it's more. 10 visits, it's more. Every single one. This is my true statement. Okay, we'll try one more example here. The linear relationships below between the total cost of snow tubing and the number of downhill rides at Fun Tubing is represented by this graph. Okay, so it looks like some sort of initial value, and then we've got some sort of rate going on. This is for Fun Tubing. The total cost for downhill rides at Lake Top, well, we've got a competing company here, is represented by the equation C equals 250N plus 10. Okay, which of the following statements is true? Now it's hard to compare because I don't really have them on the same graphs, but I think we could fix that by making a new graph. So let's talk about the number of runs and the cost. Okay, do we have an initial value? Yes, we do. Starting at $10. And for every run, it's going to go up $2.50. So 1 and $12.50. 2. And if we add $2.50, you get $15. 3, $17.50. 4, $20. Okay, let's see if that's good enough to graph. 0 and 10 is nice. 1 and $12.50. No tricky to graph. I'm going to ignore that one. How about 2 and 15? That's a nice one. And 4 and 20. 4 and 20 is about there. Okay, it seems to be following a pattern. In fact, if I count, it looks like there's dots that go in the middle right here. I can add those dots to my graph. And following my pattern, it looks like they meet right there. Okay, let's look at our statements they want us to analyze. The total cost is the same for 5 downhill rides. Well, here's 5. Those costs are definitely not the same. False. The total cost is the same for 10 downhill rides. Well, there's 10, and hey, that's the point where we said that must be true. And just to compare the last to make sure that we didn't mess up, it's more expensive at Fun Tubing, that was the original line, for more than 15 downhill rides. Well, if I were to continue my green line, I think it actually gets more expensive for the other one. Right? It's going to be above. Right? It started off cheaper, but then it got higher. So that's false. It's cheaper at Lake Top Tubing for more than 10 downhill rides. Well, no, we just said it's actually more expensive, right? So indeed, we have the right one, the true statement. Okay, there's point of intersection. Two competing things. We want to compare them. The easiest way is to look at graphs. Okay, so if you don't have a graph, make a graph, put the lines on there and start comparing things. Figure out where they meet, figure out which one's higher, which one's lower. Often we'll use those words, it depends. And give the sheet a try, and if you're stuck, come see me.